Okay. So the first topic which I'm going to take up is linear algebra. So as I think yesterday I have seen the other person speaker has given the weightage for the chapters. Majority of the questions are from linear algebra and real analysis, complex analysis. These two, if you study thoroughly, and ODE anyway, all of you will be knowing. So ordinary differential equations and PDE. These are the 5 topics, major topics, which we have to cover. So in that, for me, the assigned topic is linear algebra. But in order to start linear algebra, I should know what is meant by field. Actually, because this is the first class, so had group theory been completed, I would have started directly. But this is the first class, so first I have to start with what is meant by field. But in order to enter into this topic of field, we require the basic concepts. So please bear with me for a few minutes for teaching these basics, then we'll enter into the things. Okay. So abstract algebra will be taken by somebody, I don't know. So, but at present, I'll try to give you brief definitions only to the extent I require. So, first one, that the concept which I require is binary operation. So, because field means I need to know algebraic structure, group, semi-group, and commutative ring. So, these are the concepts. So, just briefly I'll explain, and in depth will be taught by your sir, somebody else. So, a field only to the extent I require for linear algebra, I'm going to teach you. So, binary operation. So, what is a binary operation? In order to enter into this binary operation, first we need to recall Cartesian product of two sets. You know, A cross B, a Cartesian product of two sets. In your 9th class you studied. This is set of all A comma B such that it's an ordered pair. A belongs to capital A, B belongs to capital B. All of you have studied this. And how many elements will be there in A cross B is the cardinality of A cross B is cardinality of A into cardinality of B. Okay, so this is the one. Next, here we require number of elements is A cross B, but it can be defined over some, if S is a non-empty set, then you can define S cross S also. What is S cross S? It is set of all ordered pairs, A comma B or X comma Y, anything you can give any name for this. So first element will belong to first set, second element belongs to second set. But first set is also S, second set is also S only. So it is X comma Y ordered pair. First element belongs to first set, second element also belongs to second set. But generally, students are of the impression S cross S means only X comma X. But in X, there may be different elements. Not only X, there may exist Y, some other element different from X also. So therefore, we should take all possible ordered pairs that will define what is called S cross S. So how many elements will be there in S cross S is number of elements in S cross S is number of elements in S into number of elements in S. S square, cardinality of S square will give you the required number of elements in S. Then we define what is called as the binary operation. So what is a binary operation? All of you might be knowing this. So what is a binary operation is? It is nothing but a function. What is meant by function again? So basic terminology of function. We say that f from A to B is a function, provided every element of A is associated to unique element of B. Definition is every element of A should be linked to every element of A is associated with a unique element. Associated with this uniqueness is very important. Otherwise, it is not a function. Unique element of P. So, for example, all of you must be knowing this, A, B, C, and so on. Here you might be having some elements, 1, 2, 3, and so on. Then A should be linked to only one element here, either 1, R2, R3, and so on. So it should be linked to only one of the elements. B should be linked to one of the elements. But that one of the elements can be 1, 2, 3, anything. So A can be linked to B, B can be linked to 1, it can be linked to 2 also, or 3. So, but A should be associated to only 2, B also should be associated to only 2, or 1, or 3. This is allowed. A, B, C, 1, 2, 3. So, B may be associated to 1, or it may be associated to, or it may be associated to 3. But this is two different elements are connected to one. This is a function. This side is allowed. This is what is called many to one function. This is provided if you join this. This is one to one function because single element is connected to single element of B. But this is not allowed. One cannot be connected to two different elements. This is not allowed, not a function. So if F is connected like this, A to B connected like this, it is not a function. Why it is not a function? One element is having two connections. That is, it is associated with more than one element. Here definition is it should be associated with unique element. This is allowed. Two different elements can be connected to one, but one element cannot be connected to two. It is like two different students can get same marks. All students also can get same marks, but one student cannot get two different marks for the same exam. For different exams, definitely allowed. Only for one exam, student cannot have two different marks. Same student cannot get 25 out of 25 as well as 0. Is that not? So one student for the same exam, he cannot get two. So this is not allowed. This is not a function. This is a function. This is the best example. Now, so for a binary operation, let S be a non-empty set. If S is any non-empty set, then a function, it is denoted by F, S cross S to S, a function defined like this, is said to be a binary operation. So this is denoted by F, or it is also denoted by, generally by a symbol, circle or star. Instead of F, you can take circle, star, or F, is said to be binary operation, provided it satisfies two conditions. Very important. Two operations. Because when you come for interviews, you people, what problem we face is, you can fly in the sky but cannot stand on the ground. This is the problem you face. When you come for demos, generally in the interview board, what we observe is, basic things you are not able to define properly. So this is very important. When is it said to be binary operation? It is said to be a binary operation, provided it satisfies two conditions. What are the two conditions? Whenever you take A circle B belongs to S for all A comma B belonging to S, it will be defined for every ordered pair. S cross S means there will be two elements, A comma B belonging to S cross S. But after applying this operation circle, this A circle B, A comma B belongs to S cross S, the domain, we have to link it through circle. Then the output should belong to the codomain S. Second condition is, A circle B must be unique. Must be unique. A map, if I say function, second one not required, because in the definition of function itself, unique, the word is there. But a map F from S cross S to S is said to be binary operation, provided it is satisfying two conditions. So the map is defined like this. First one is it should belong to S, it must be unique. This is very, very important axiom. Generally, students, they don't state this. So if you say it is a function, then you need not define second condition. If I say it's a map from S cross S to S, then two conditions are must. Sometimes this map may not be satisfying the second condition. So if it satisfies first one, then this axiom, A circle B belongs to S for all AB belonging to S, this axiom, this is what is called as, you must be knowing, closure axiom. Then majority of you should understand what is the difference between closure axiom and binary operation. Most of the students, they cannot identify the difference. The difference between closure axiom and binary operation is, if it is closed, it may not be binary operation most of the times, even if it is closed. Why? Because uniqueness may not be satisfied. So this uniqueness is must for binary operation. Sometimes uniqueness is satisfied, but it may not belong to us. So therefore, it's a binary operation only when it satisfies these two conditions. These two are called axiom 1 and axiom 2. So generally, binary operation means when the interview also you people will be saying, what is the example of binary operation means? Always all the students, they will be giving majority of the students always natural numbers are s equal to z, set of integers 0 plus r minus 1 and so on. This is set of positive integers. And you must be knowing the sets s equal to q, that is set of all rational numbers of the form p by q, where q is not 0, p and q are integers. This is very important. And set of real numbers, that is nothing but rationals union irrationals. The one which is not rational is called irrational, denoted by r minus q. And another set generally we'll be considering is under modulo system, set of all possible reminders. When you divide a number by n, that is Zn 0, 1, 2, 3, and so on up to n minus 1. Because when you divide a number, any integer by n, any integer by n, possible reminders are this. You know, according to division algorithm, whenever you divide a by b, b should be not 0. Then according to division algorithm, there exists whenever a and b are integers, then there always exist two integers q and r. So satisfying the condition b is equal to aq plus a is equal to, that is b is a divisor, then a is equal to bq plus r, where r is remainder, q is the quotient. Q can be negative, q is any integer, but r must be positive integer. It should be less than or equal to the divisor. B is divisor, this is dividend. Dividend is equal to divisor into quotient plus the remainder. Remainder must satisfy the condition r should be greater than or equal to 0, less than the divisor. So r can be 0 or it should be positive and strictly less than the divisor. These are the two requirements. So if r is 0, then a is equal to bq, then we say a is divided by b. So that means b divides a, or a is said to be divided by b, or a is said to be multiple of b. Q can be negative, but remainder cannot be negative. It should be less than modulus of b. Why modulus is? Because a can be negative integer also. So remainder should be less than positive of b, because b can be negative. Because it's an integer, it can be negative. But remainder should be positive less than b. Because if b is negative, then r is already positive. It cannot be less than the negative number. You should have modulus of b. This is what is called division algorithm. So the possible reminders when you divide any integer by n, what are the possible reminders? 0, 1, 2, 3 up to n minus 1, because it should be less than n. Less than n means 0, 1, 2, 3 up to n minus 1, because remainder should be negative. And it, that is here Zn means remainder is, the divisor is n. So when you divide any number by n, n is an integer, so remainder will be equal to positive or 0, positive less than the divisor. Our b is n here, suffix denotes this. So it should be up to n minus 1. So that is how you get Z5 means. What are the possible reminders? This is set of all possible reminders when an integer is divided by 5. This is 0, 1, 2, 3, 4. Because less than 5, these are the possible reminders. Now we use a symbol. I require that symbol also. Generally Z5 star. What is Z5 star is? Only positive sets. But generally, this is not given. Whenever this is with the into the binary operation, then we have to understand that this is starting, whenever they say it's a group, then we have to understand that it is starting with 1, because if 0 is there, it cannot be a group. So remember, whenever it is with into symbol, even though Z5 is there, we don't take 0. Okay. If it is with the plus symbol, we include 0 also. Remember this. This will be following this notation. In all textbooks also, it is given like this. Okay. So this is the notation generally followed. There will be confusion for the students. So I'm telling this. Next one we have, these are the sets we are going to use. And we use another symbol, mn by n over r. or we also use the symbol MNR. What is the meaning of this is, the suffix indicates the order of the matrices, set of all matrices of the order n by n, and inside entries are real. This is what is the meaning of Q. R, if inside Q is there, Aij belongs to Q. If inside C is there, that is Aij belongs to C. If there is Z, that means inside entries belongs to Z. If inside is some Z5, what is the meaning is, inside entries are belonging to Z5. Aij belongs to Z5. So inside, the nature of the elements Aij is decided by this set, which is inside. This is the general notation that we are going to follow generally. Now come back to our present topic, that is binary operation. So which of the following are binary? Generally, whenever you give an example, set of natural numbers, I want to know whether under addition it is a binary or not. All of you can answer, because sum of two natural numbers is automatically a natural number. All of you know. So there is universal proof. Sum of two natural numbers is always natural number. When you add two numbers, you will get unique output. If you change the numbers, you will get different answer. Generally, students are having an impression. Unique means you should get same answer. No. Corresponding to that pair, answer should be unique. For example, if I take 2 and 3, 2 circle 3, 2 plus 3 is 5, which is again a natural number, which is unique. When I'm adding two numbers, I'll get only 5, which is unique. I will not get two answers. For example, if I change the numbers, definitely answer is going to change. Unique does not mean you will always get same answer. No, corresponding to this pair, answer should be unique. If we change the pair, automatically answer may change. So uniqueness you have to understand carefully. Corresponding to that pair, you will get only one answer. Then it is a binary operation. So plus is binary on natural numbers, binary on n. Similarly, binary on z, because sum of two integers is integer. Sum of two matrices of order n by n is again a matrix of order n by n. So plus is binary on n, z, r. Here plus means addition of matrices. Here plus means the plus as you add natural numbers z and r. This you have to understand according to the context. This plus on mn means addition of matrices. This plus on z means how you add integers. Similarly on R, if I define on C, you know how to add complex numbers, real part plus imaginary part imaginary. So that's how the plus is denoted. This is a symbol. This is not only ordinary plus, it is a symbol. That's how it is defined. So it's going to be binary universally on this. But if I take, for example, on natural numbers only minus, if you take, then I want to know, is it binary on n? Is it binary on n? Is it binary on z? Question mark. Any one of you, can you tell me, is it binary on n?
No, ma'am.
No. Why it is? No, it is not
Binary
binary.
on-
But
it
is it binary on
Z.
z or not?
Yes.
Yes. Why it is
It is
not binary
binary
on
on
n? Because n, if you take 1, 2, 3, 4, and so on. So then if I take a equal to 1, b is equal to 2, then what happens? 1 circle 2 will be 1 minus 2 minus 1, which does not belong to n. Generally, students will get it out. Why are you taking like this? If I take a equal to 2, b equal to 1, then 2 circle 1, 2 minus 1 is 1, it is there. So your student will put this question, madam, if it is like this or like this, then it is satisfied. Why it is, if you take the other way, why cannot we call it as binary? Because this way it is satisfied. Answer for that is, a circle b should belong to n for all a comma b, whatever may be the values. If you take for one pair, it is satisfied. For one pair, it is not satisfied. Then it is not a binary operation. Minus is not binary on, simply you should not leave. Minus not binary on n. You have to mention the set. Some students, they will simply say in the interview also, minus not binary. Like this, the answer. So that is not correct. This is binary or not depends on the set also. Same minus, if you take for integers, a circle b is equal to a minus b automatically belongs to z for all ab. Because difference between two integers is always an integer. Here, what is happening for natural numbers? If it is minus, minus numbers are not there in n. But whereas in case of Z, Z includes 0 plus r minus 1 plus r minus 2. All are included. So you will, whenever you take two integers, only three cases arises. What are the three cases? A may be greater than B, A may be equal to B, A may be less than B. If A is greater than B, then A minus B will be positive integer. Still it is an integer, so it is belonging to set. A minus B will be 0, 0 is an integer. And here A minus B will be negative. So obviously this also there in set. So in all possible cases, for all means what? Whether it is positive, equal, negative, in all possible cases, you have to test. If it is satisfied only, we can say it is binary. So same this one operation, it is binary on set. Very important. But whereas it is not binary on n. So therefore, not only this is important, operation important, set is also very, very important. So you have to take care of, you have to check with respect to sets as well as with respect to the operation. So minus is binary on Z, minus is binary on R, because difference between two real numbers is a real number, and it is binary on Q, it is binary on C, it is binary on Mn. Minus means difference between two matrices, you know how to find out. So A minus B means A plus minus B. So it is again, it will be of same order. When is element going to be in this? Provided, again it is an n by n matrix. When you subtract two n by n matrices, you will get n by n only, and it is there in R also. Not only M and R, some students may say, even if it is M by n R also, it is binary. Because difference between two matrices of M by n order will be again an M by n order matrix. Inside entries will be real because difference between two real numbers is real. So you have to understand according to the concept. So minus is not binary on this. So binary means not only it is there in that set, output should be unique. So this I am specifically saying. So when you go for interview, they will ask you, can you give an example where it is not unique? Majority of the students, you are able to define binary, simply you are giving all these examples. So when as an examiner, even if I may ask you, can you give an example of an operation where it is not binary because of violation of second axiom? First axiom here happily satisfied. So it is in on all these sets. It is not satisfied in case of natural number. A circle B does not belong to this, therefore it is not binary. Why? Because first case is violated. What is the first condition? Not binary on n. Why it is not satisfied on n? Why? Because first condition is not satisfied. Okay, but you may be asked to give an example where second condition is violated. First condition satisfied, but second condition is violated. What is second condition? Uniqueness. Can you give an example, any one of you? It is not binary. Can you give an example? Can you give example of not binary, of an operation which is not binary, of operation example where operation is not binary because of violation of second axiom. Violation of axiom 2. What is axiom 2? Is not unique. Two axioms. First axiom is A circle B should belong to n. Second one is violation of the second one. Can any one of you give an example? Going back to the definition, two conditions I said. This is first axiom, this is second axiom. If in natural numbers, minus is not binary on n because this is not satisfied. So A circle B must be unique is the condition. Can you give an example of an operation where A circle B belongs to S, but it is not unique? I'm asking you that example. Anyone of, because you're all PG, completed PG. Is it not? So this is very basic. Where axiom 2 is not satisfied, violated. Majority of the students, they're not able to answer this. Yes, shall I give or any one of you are ready to give?
Ma'am,
Hmm.
not getting the idea.
Not getting. So others also. No. So this is the basic. So next time when you go for your interview, JL or DL, you should be able to answer this. This is very simple. So I'll give you some questions. From there, we'll try to get an example. So let us see some questions. Which of the following are binary? Are binary? If not, for this group theory, best one is the textbook is John B. Fraley. Fraley is the best book for you in the entrance point of view. The first course of abstract algebra. First course of abstract algebra by John B. Fraley. This is the best book for you in the entrance point. If you can work out, no answers will be there in that, only questions will be there. No model questions will be there. So if you can answer the questions which are given in that, definitely you'll crack any exam. John B. Fraley. So you can download from this PDF also. It is available online, or you can buy if you wish. So that is one of the best textbooks. Which of the following are binary? If not, which axiom is violated? If not, which axiom is violated? If not, state which axiom is violated. I'll give you a first question. On Z plus, you can also note down and try. On Z plus, A circle B is equal to C, where C is an integer greater than both A and B. They are getting basic questions in CSIR also, like this. Options will be given to you. Second one, on Z plus, A circle B is C, where C is the smallest integer greater than both A and B. A circle B, I'll work out all this. Where A star B is C, where C is at least 5 more than A plus. 5 more than A plus. Very interesting question. And A star B, C is the largest integer. Number 4. On Z plus, A star B is equal to C, where C is the largest integer, less than the product of A and B. Less than the product of A and B. Largest integer less than the product of A and B. Number 5. We have on Z plus, A star B is A power B. Very interesting. Number 6. On Z, A star B is A power. Let us work on this. First one. Let us go with first one. Always you find questions in majority of the textbooks. Only A circle B means A plus B. Binary operation means plus minus. Only these two things you are learning. But there are many binary operations like this. So on Z plus, A circle B is C, where C is an integer greater than both A and B. So let us go with this. Okay. So is it binary or not? I want to know. On Z plus, of course. So let us show. Can you tell me, is it binary or not? C is an integer greater than both A and B. The difference between first and second is, it is the smallest integer or greatest integer, the word is used, that's it. So let us see whether it is working out or not. A star B. Okay, so let us see this. Let's copy.
Bottom select angle.
No. Why it's no? Why it is not a binary operation?
A circle B equal to C means there is no connection between C and A B.
Oh, no. Your answer is correct, but justification is not correct. For example, A is 2, B is 3. Then what is A circle B? 2 circle 3. So what is 2 circle 3? It is C. What are the values of C? What is the integer which is greater than both 2 and 3? Can any one of you tell me what is the number which is integer which is greater than both 2 and 3? What is the integer greater than 2 and
4
3?
or 5 we can take.
4 is greater than 2, greater than 3. Even if I take 3, 3 is greater than 2, but 3 is not greater than 3. It should be greater than both A and B. 3 is greater than 2, but 3 is not greater than 3. So I cannot have 3. 4 is greater than 2, 4 is greater than 3. It should be greater than both. So 4 is included. Next, 5 is included. 5 is also greater than both 2 and 3. 6 is. How many values are there for C? C belongs to this set. What are the outputs of C? 4, 5, 6, any one. C belongs to this set of all that, any one of them. So C can be 4, C can be 5. How many values we are getting for C is, all of them belongs to Z plus or not? Exactly. They are all positive integers. They are there in the set S. A circle B belongs to S for all A comma B S. But is A circle B unique? Is A circle B unique for one pair only?
No, ma'am.
For one pair.
One pair it
Pair
will be
only, you are getting so many answers.
not unique.
So for one pair, 2, 3 only, we are getting so many outputs. Therefore, second axiom is violated. This is one of the best examples. When you go for your interview, you should be able to generate examples. Written exam is different. You will be able to answer because no one will be before you. You can spare your own time. But in the interview, you will be asked to create examples. This is the main difference between entrance and interview. People are afraid of interview only because of this. You should be able to create there and then examples, counter examples. You should be so fast. So A circle B is C, where C belongs to S, but it is not binary. Circle is not binary because for 1, see, 1 plus 2 is 3 natural numbers. 2 plus 3 is 4, 5. Get different answers. Even then, it is binary operation. Plus is binary. Why? Because for one pair, you are not getting 2 answers. For different pairs, you are getting different answers. You should understand uniqueness carefully. If you change the pair, you can get different answer. But for one pair only, you should not get 2 answers. Here, I have not changed the pair. For 2 and 3 only, I am getting so many answers. So, not binary, as A circle B is not unique. As A circle B is not unique. One of the best examples. Emma, all of you understood? This is best example. When you go for interview, this helps you a lot. Next one. Let us go for second one. What is the difference? Same on A circle B, C, where C is the smallest integer greater than both A and B. Here, it is an integer greater than both A and B. Here you are given it is simply, it is the integer greater than both A and B. Only difference is the word greater than is important. So let us see. Emma, is it clear? Why it is not binary? Hopefully all of you have followed. So now
Yes, ma'am.
the same set, 1, 2, 3, 4 only, but circle is same operation. It is A circle B is defined as A circle B is equal to C, where C is greatest integer. The word greatest is introduced. Greatest integer greater than both A and B. Greater than both A and B.
No, ma'am. Smallest integer greater than.
Smallest integer greater
The word
than
only
both A
greatest
and B.
is the only difference. Let us see again. So what is the output for 2 circle 3 only? I am giving an example. With example, you should not prove, but for you to understand, I am giving an example. So earlier we got, this is belonging to, what are the values of C? We got 4, 5, 6, and so on. So C is having many, but here it should be greatest. We got 2 circle 3 C, but now circle means it is greater than both A and B, greatest integer. Greatest integer greater than both A and B. Greater than both A and B. Now, can you tell me, all these are greater than both A and B. What is the greatest integer? What is the greatest integer? There will be only one greatest integer. So 4, 5, 6, and so on. What is the greatest integer?
Not defined, ma'am.
Not defined. It is going up to infinity.
Infinite.
Infinite. Infinity is not not part of number system. Therefore, even though it is unique, but that unique number is not finite. Here, greatest integer is infinity, but it is not an integer. It is not part of number system. It is unique only, but not finite. Therefore, not only unique, it should be finite also. So C is greatest integer, and it is not finite. Therefore, C is, so such a C does not exist. So C, such a C does not exist. Why? Because infinity is not part of number system. So therefore, we say it does not exist, hence it is not binary. I will change the question. I will change it to 2 star, one more. Instead of greatest, if I keep smallest, will it be a binary operation? This is 2 star question.
Yes, ma'am.
So S is Z plus only. A circle B is C, where C is smallest integer. Generally, students are of the impression, greatest, smallest, if it is there, it is binary. So wantedly I have given there. Even though greatest integer is infinity, unique, it is not finite. It should be finite also. C is smallest integer greater than both A and B. Greater than both A and B. This is the question. So as somebody said, I think Nagarani. Nagarani, Nina, am I correct? Somebody said smallest integer means yes, it is binary. So A is 2, B is 3. A circle B is nothing but 2 circle 3 is equal to C, which is 4, 5, 6, and so on. So in this, we want smallest among them. So C is equal to smallest of all, which are greater than this. Smallest is 4. So C is 4, which is unique, which is there in Z plus and is unique. Even if I take A equal to 1, B equal to 1, least A circle B is equal to C. What will be C? 1 circle 1 is C, which is smallest of the integers which are greater than both 1, comma 1. What are the integers which are greater than 1, comma 1? What are the integers greater than 1, comma 1?
2, 3, 4.
2, 3, 4, and so on. What is smallest among them? 2.
2.
Is it there in Z plus or not? Yes. Is it unique or not?
Yes.
Therefore, it is binary. Is it finite or not? Yes. Finite, unique, corresponding to this pair. Corresponding to other pair, 4 is finite. That means corresponding to each pair, your C is unique. Not only that, it will be finite. You can check. Therefore, it will be true for all AB. A greater than B, A equal to B, A less than B, even if you take also, it will be satisfied. Therefore, we can say that the circle is binary. Binary on Z plus. Binary operation on Z plus. If we change the set, it is there, it is binary or not, we don't know. We have to check. But only with respect to the given set of natural numbers, it is binary. Is it clear, ma? So simply by looking at greatest, smallest, you should not conclude it will be binary. Generally, students will be memorizing like this. If it is without greatest, smallest, it will be binary. So if it is small, you should not remember like that. Not only greatest, smallest, the output should be unique. Sometimes wantedly just to tease you, examiner may give like that. Say the word greatest is used. Most of the time, if the word greatest, smallest is used, it may be, not necessarily must, maybe, most of the times. But you should not conclude. There are examples where it is unique, but it may not be finite. Okay, sometimes it may be unique, but it may not be there in the set. Then also we say it is not binary operation. Clear? I think you got clarity now. So when you go for interviews, prepare like this. This is one of the finest examples. Next one you see, another one on Z plus A star B equal to C, where C is at least 5 more than A plus. Is it binary or not? At least 5 more than A plus. Is it binary? At least 5 more than A plus. A circle B is C, where C is at least 5 more than A plus. Can you say it is binary, ma? Any one of you? Earlier we have seen greatest, smallest.
Yes, ma'am.
Now at least, at the most, if they are given, will it be a binary operation? At least 5 more than A plus. What is the meaning?
Yes, ma'am.
Any one of you are you
Yes.
ready
Yes, ma'am.
to answer? I should not kill
No, madam.
you. I should not kill you. At least 5 more than A plus B. You are saying it is yes. So Sarita, she is saying no.
No.
No, why it is no? Why it is no?
Suppose
So not a
if we
binary
take,
operation is correct answer. Circle is not a binary operation. Correct. Justification. What is the justification? That is what is C actually. At least this you have to, this phrase you have 5 more than A plus B. 5 more than A plus B means A plus B plus 5. Greater than or equal to. At the most means less than or equal to. Always P greater than or equal to A plus B plus 5. Now, as somebody said, I don't know what is his name. If you take B is equal to 1, then what will be A circle B? 2 circle 1, which is equal to C, which will be greater than or equal to 2 plus 1 plus 5, which is 8. That means C is greater than or equal to 8. So is it unique? What are the numbers which are greater than or equal to 8? That means 8, 9, 10, and so on. How many outputs you are getting? Infinitely many. All of them are there in Z plus or not? Yes.
Yes.
But are they, is C unique? No. For same pair, only one pair, we are getting so many. So for one pair, if you get many, then it is not a binary operation. So this is also one of the best examples where it is not binary. Therefore, circle is not binary on Z plus. Not binary on Z plus. Sometimes in CSIR exam, in the part A, he is defining like this and asking you to give some what is the output of this? You can find such questions in part A of the CSIR. So in part A also some operation will be given. What is the value of this? The value of this is. So like this, some new operations he is giving. So not subject related, but it is an operation. So you are getting such questions in the part A also. That is helpful for this particularly. Not only the subject point of view, helpful like that. So next question. So third one over completed, fourth one. Clear, no? So this is the one. At least don't conclude. If at least is there not binary, at the most is there not binary, like that. You have to do, depends on the greatest is there binary, smallest is there binary, greatest not binary, like that. You should not. Okay, let us. You have to work out because it depends on the set. Binary operation depends on the set. So very important is that. Next one, ma, A star B, where C is at least as third one completed. Fourth one, A star B C, where C is the largest integer less than the product of A and B. Largest integer less than the product of A and B. Largest integer. So fourth one, A circle B is C, where C is largest integer less than the product of A and B. Any one of you, can you tell? What is the set? Set is set plus. 1, 2, 3, 4.
No, ma.
Why no?
We can find so many C values
Tell
greater
me,
than the product.
give me an example.
1 star 2 equals to
1 A equal to 1, B is equal to 2. 1 star 2, 1 circle 2. That is a C. What is C?
product is
Largest
2.
integer less than product. So largest integer less than product of A and B. What is product of A and B?
2.
Less than 2, what are all the integers? Less
One.
than 2, what are the integers?
1
One
more.
mark. No minus.
Actually, from minus infinity you can take.
Yes.
What are all the integers? C is equal to largest integer less than minus infinity. Integer he is saying take from minus infinity up to minus
None.
2, less than this, minus 1, 0, 1. Largest of this. Less than 2 integer means you can take from less than 2 integers are 1, 0, minus 1 and so on. Less than 2 means all these integers will come. Is that not? So these are all the integers less than 2. Among them, largest we want. What is the largest?
One.
One. One. Largest is 1. Is it there in this set or not? Is it a positive integer or not? Yes.
Yes, ma'am.
Is it unique or not?
Yes.
For one pair, you are getting only one answer. So it is unique also. Therefore, we say that this A star B, we cannot conclude. Circle is binary, therefore. So the reason for what Sarita said is incorrect. It is not binary is correct answer. But reason is not correct. Can you, any one of you, can you give an example where this is not satisfying? That is, it is not a binary operation. Why it is not binary? You are getting unique only. It is there in Z plus only. Largest integer less than the product. First find the product. List out all the integers less than that. Then largest among them you have to take. First what we have to do? How it is defined? Largest integer less than A and B. Product means A into B. Sum means A plus B. So largest integer less than product. Less than product. Product of A comma B. What is product of A comma B means? A into B. Largest integer less than product of A comma B. Product of A comma B is A dot B. Less than that largest integer. Less than 2, what are all the integers you list out? Then among them largest. Is it an integer or Z plus or is it in Z plus or not? We have to check. Is it unique or not? We have to check. So both are satisfied here. So what Sarita said for this pair is satisfied. So, but it is there. So we cannot say it is not binary because this pair is satisfied. Can you give another example?
Different pair, it give different values, ma'am.
Oh, it can be different values. For different pairs, you can get different. For different pairs, you can get different.
Unique.
For different pairs, if you get different answers, it can be binary. For example, in natural numbers also, 1 plus 2, 3, 2 plus 3, 5. 2 different answers you are getting. So it is still binary. If you change the pair, you can get different answer. But for same pair, you cannot get two different answers. For same pair, for example, earlier 2 and 3 we took. For same pair only, you are getting many. Rule is for one pair, you should not get more than one. Change the pair, you can get different. Here also, if you change the pair, you will get different. But still, it is not binary. Why it is not binary? Can any one of you, can you give an example? Can you give justification why it is not binary? This is interview question. MCQ, the difference is that only. In the MCQ, you will write binary or not means not binary. You will get the marks, you will clear your CSIR, you will clear your all your exams, JL, DL, everything. But when you come for interview, this is the problem we face. You are not able to justify. Intuitively, you are having a feeling that it is not correct, not binary. But why you are not able to? Any one of you, still you have an option, or you want me to answer?
If we take
Madam, if A
one
is equal
circle,
to 2,
one
B
dot,
equal to 1, we get the same answer. No?
A equal to 1, B equal to 1. What is the answer?
one circle, one, if we take
What is one circle 1?
1.
You tell me. Largest integer less than the product. Less than largest integer less than product. A into B. A into B is 1. What is the largest integer less than 1? Less than 1, what are all the integers?
0, ma'am.
Minus
0,
infinity,
minus
minus
1,
one.
minus 2, and so on. Okay. Less than 1 means
It-
this.
It is not in the
Okay.
set.
Less than 1 means this. So what is the largest integer among them? So it is, what are the integers? Less than 1. Less than 1 integers are
0.
minus 4, minus 1, 0.
Infinity.
What is largest among them?
0.
0. Unique only you are getting.
Yes.
Unique only you are getting. But is it binary?
No.
Why not binary?
Does not belong Z plus.
Not in
Correct,
the
good. Correct, good. Excellent. Does not belong to set class.
does not belongs to the set.
So you take any other pair other than these two. Who has given this? May I know your name, sir?
Shankar, madam.
Shankar. So A equal to 1, B equal to 1. Excellent example. So 1, 0, 1. So for this pair, if you take any other pair, it will be satisfied. Only for this pair. Remember this. This is the interview question again. So can you give an example where this operation will be given to you by the interview board member? So is it binary or not? You will be asked to. If not, why? If so, why? Like this, you are getting questions in the interview. So very important is A circle B is 1 circle 1, which is 0. It is unique only, does not belong to set plus. So it is not binary. So this is very important. So not binary. So this is not binary. Not binary. Because it is violated. Satisfied for all pairs except this pair. This is exceptional. Only for this pair it is not satisfied. So or in the interview, you may be asked to answer for which pair it is not satisfied. Can you give an example of the pair for which it is violated? Examiner only will give you the board member only will give you the answer. It is not binary. Can you tell me why? Can you give an example where it is violated? This is like this interview goes. Okay, so not only that, in the entrance also. So in the entrance also question may be given. This is not a binary operation because, or like this options will be given. So you should know justification also. Okay, fine. Nagai sir. Hello.
Nagai.
Sir, shall I run or shall I discuss examples like this? Do you want me to run?
As you wish, madam. Once you ask
No,
the
no.
student.
What is Z? Had it been, it would, if it is Z, what happens? You tell me tomorrow. Is it binary or not? Because Pranati has given the question, take S equal to Z. If it is Z, then is it a binary operation or not? Please note this also as homework question. Not only those two, Pranati, take S equal to Z and test whether it is binary or not. Not only for Pranati, it is for all. Now it is Z plus ma. Pranati, did I answer your doubt?
Yes, yes, ma'am.
Because 0 is not there. Okay, ma? So now it is not binary because if the S is equal to Z, Is it binary? This is
Yes,
form
ma'am.
of binary. Is it? No, no, don't tell now. Tell, give answer in the WhatsApp group. Is it binary? Okay. You test and then tell me. You have to take negative integers also. Don't be happy. Not only for this pair. Whenever Z means, you have to take when both are negative, when both are positive, when both are equal, one positive, one negative. All cases you have to test. Simply don't say yes. You have to test all cases. Okay. And tell me or post in the WhatsApp group. All of you, please take these 3 questions as examples. Next one. So this is the one where it is not binary. So still we have seen there are certain operations which are binary. There are certain operations not binary because of violation of first axiom or violation of second axiom. So this time, sir, I would like to continue the class as if in the interview point of view also. Some questions at least which will come in the interview, which they are not able to answer. So those questions also we'll discuss in the coaching part, in the part of the coaching itself. So it helps you not only for this, for the interview also, written exam as well as interview also. Some questions, not all the questions. At least some questions like this. You'll enjoy doing them. Okay. Now, next question is here, binary operation we have completed. Next, there are certain which are binary, there are certain which are not binary on the set. Binary operation depends on the set or not? Yes. So, next question is algebraic structure. This is the basic unit for the algebraic structure. So, what is algebraic structure is a non-empty set along with binary operation, a non-empty set along with binary operation, is called with one or more binary operations is called an algebraic structure. So now we have seen in group theory, we are going to have only one binary operation. In ring theory, we are going to have more than one binary operation. So what are the algebraic structures? Natural numbers along with the plus, because plus is binary on n. Z along with the plus as well as with the minus, because difference between two integers is an integer. Minus is not binary on n, but it is binary on z. And you can have r along with the minus, r star along with the multiplication, r along with the plus. So again you have q along with the minus, etc. These are all algebraic structures. And you can have more than one also. On z along with the plus and minus, it is algebraic structure. Plus and dot, it is algebraic structure. So algebraic structures may be having one operation or more than one operation. So like this. So this is Q along with this and so on. So operations algebraic structures may be of this type or of this type. These operations will come in ring theory. Here, these operations will come under group theory. Next one. So n comma minus is not binary. Is a structure. Every structure is not an algebraic structure. It is a structure, but not an algebraic structure. Next, let us go for an axiom. First one is satisfied. So whenever it is algebraic structure, automatically with respect to plus, it is going to be closed. Closure axiom means a plus b belongs to n for all a comma b. Closure axiom. It will be unique also. Once the word algebraic structure is used, automatically it is closed as well as the output is unique. So we have seen some structures where it is closed but not unique. So if only closure axiom is satisfied, then it is what is called groupoid. What is groupoid? If S is any non-empty set, and non-empty set, S is any non-empty set, and A circle B belongs to S for all A comma B belonging to S, then S comma circle is called groupoid. It is a structure. I am not saying it is algebraic structure. S comma circle, then the structure is different. Algebraic structure is different. Then the structure means any set with some operation. This is a structure. This structure is said to be groupoid provided it is belonging to S. That is, closure axiom is satisfied. That is, closure axiom satisfied. If simply closure axiom is satisfied, then it is said to be groupoid. For example, n comma minus is not a groupoid. It is a structure, but it is not groupoid because minus is not, that is, n is not closed with respect to minus. So, a groupoid, if closure axiom is satisfied, that is, set is this minus operation, that is, set is not closed with respect to operation. So, set is not closed with respect to operation, then we say it is not a groupoid. For example, the difference is sometimes it may be groupoid, but it may not be by algebraic structure. It may be groupoid, but it may not be an algebraic structure. For example, earlier we have seen C is last, that is that operation S equal to Z plus, the operation circle, where circle is at least a circle B is equal to C, we have seen, where C is at least 5 more than, this is not, no, that is the largest integer, smallest integer less than both A and B. We said it is binary operation. It is binary operation. The smallest integer less than A and B. Is it binary operation? Less than, greater than both A and B, sorry. Earlier we have seen an example. Greater than both A and B is binary. Operation is binary. So, circle is A, circle B, C is unique. Therefore, this Z plus along with the circle is an algebraic structure. Algebraic structure. But same thing is an example. But same set, if you change the question, same set, S is equal to Z plus only, A circle B is C, where C is smallest not given, greater than, integer greater than both A and B, greater than both A and B is belonging to Z plus. A circle B is equal to C, we got integers. So automatically we say it is closed, but it is not a binary operation. Why it is not binary? We are getting many answers. Output is not unique. But C is not unique. Not unique. So in this case, hence not binary. Hence not binary. Therefore, this Z plus comma circle is a structure, is a groupoid, but not an algebraic structure. Why it is not an algebraic structure? Because circle is not binary operation. It is a groupoid. Closure is satisfied. What is closure means? A circle B should belong to Z plus. It need not be unique. It is there in Z plus, but it is not unique. Therefore, it is closed. This is closed. Z plus comma circle is closed. Closure axiom is satisfied, but not unique. So C is not binary. Hence, this is groupoid, but not an algebraic structure. So in the interview also, they may ask you, can you give, or in the CSIR paper or SET also, or in your JL, Z plus comma 0 is option A, groupoid. It is not, it is a structure, it is an algebraic structure. It is both groupoid and algebraic structure. Like this, options will be given to you. So Z plus comma 0 is a groupoid, but not an algebraic structure because circle is not a binary operation. Hardly very few people know this. So now, very important is every algebraic structure, very important. If it is algebraic structure means closed as well as unique. Structure means may not satisfy uniqueness. Every algebraic structure is a groupoid. Very interesting. Because if it's algebraic structure, automatically that is, this is a S comma circle is algebraic structure means automatically it will satisfy two conditions. Structure means circle is binary. Binary on S. Because a set along with the binary operation is called algebraic structure. Algebraic structure itself means this is binary. Binary means it is going to satisfy two conditions. A circle B is there in S. Second one, A circle B is unique. So is A circle B there in this or not? Yes. If this is satisfied, sufficient. It is satisfying something extra also. We require this. Therefore, automatically it is closed. If it is closed, sufficient for us. It is an algebraic. So every algebraic structure is a groupoid. Sorry, spelling mistake. Is a groupoid. But every groupoid need not be an algebraic structure. Converse is not true. For example, this is a groupoid. Previous example. This is a groupoid, but not an algebraic structure. Every algebraic structure automatically groupoid. But if it is groupoid, you cannot say it is a algebraic structure. Interesting point. Any doubt in this? I hope you got some clarity now. Next one. What are the examples of groupoid we have seen? What are the examples of not groupoids we have seen? And we have seen a structure which is a groupoid but not an algebraic structure. That is the difference between structure and algebraic structure. Next one is semi-group. We require all these terminologies. Semi-group means, so a structure, an algebraic structure. Whenever I say algebraic structure, automatically closure is satisfied. Algebraic structure, if it satisfies, if it is associative, if it satisfies, associative axiom. What is associative axiom? With respect to circle, associative axiom. A circle, B circle, C is equal to A circle B, circle C for all A, B, C. Belonging to X. If it satisfies this axiom, then it is called semi-group. Now, all of you know this. So, algebraic structure means it is automatically closed. Associative is also satisfied. That means when is a structure, when is it going to be this provided? It is closed, if it is a binary operation, closed and associative, then only it is semi-group. Remember this. Semi-group means closure as well as associative. An algebraic structure, that means S should be non-empty set, circle is binary. If it satisfies associative axiom, then it is called a semi-group. Now the question is every semi-group a groupoid? Can you tell me? Question is every semi-group a groupoid?
Yes.
Every semi-group, is it groupoid or not?
Yes.
A groupoid? Yes or no?
Yes.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Why yes? Because semi-group means closure is satisfied, something
And unique
extra,
also.
associative
Unique
also is
also.
satisfied. So
Mm.
only closure sufficient for groupoid. Semi-group means two axioms, closure and associative. So if it is a semi-group, automatically it is satisfying closure axiom. So automatically it will be a groupoid. Answer is yes. Next, is every groupoid a semi-group? Is
No.
every
No.
groupoid
No.
a semi-group? What is the example? Can you give an example of a groupoid which is not semi-group? Semi-group means closure as well as associative. Both should be satisfied. Can you give an example of a groupoid? Groupoid means only closure. Semi-group means closure and associative. Can you give an example
Set of natural
where it
numbers,
is
ma'am.
groupoid? not associative. So answer is no. Yes, tell me example.
Natural numbers, ma'am.
Natural numbers with operation also you should give structure.
Like
Algebra.
subtraction, ma'am.
Subtraction, it is not groupoid. I want an example of a groupoid which is not semi-group. Every
Yes.
groupoid is semi-group, answer no. So I want an example. Example of groupoid. Example of groupoid which is not semi-group. Can you give me an example? This is the question I am asking. Yes. Dash. Yes. Any one of you. It should be groupoid, but it should not be semi-group because you only said no. If it is semi-group, groupoid. But if it is groupoid, is it semi-group? Every groupoid, is it a semi-group or not? Options will be given. Entrance question. Or which of the following is an example of a groupoid which is not semi-group? Options will be
A
given.
star B equal to A power B.
That we haven't completed. Very simple
Okay.
example you give.
Um,
Very simple examples are there. Example of algebraic. Example of structure.
A circle be
Neither-
equal to C, where C is smallest integer.
Give me simple examples. Not groupoid, neither groupoid nor semi-group. Not both are not satisfied. What is the example?
Z comma minus, ma'am.
Correct, good, excellent. Who is this girl?
Kavya.
Huh?
Kavya.
Kavya, good,
Yeah.
good, excellent. Z comma minus is groupoid
Groupoid.
because A minus B belongs to set. Difference between two integers is an integer. Therefore, it is a groupoid. But it is closed. It is a groupoid, but it is not semi-group.
Semi-group.
Not semi-group. Why? Because minus is not associated.
Association.
As A circle, B circle, C not equal to A circle, B circle, C for minus. Because A minus B minus C not equal to A minus B minus C. They are not equal. You can see A minus B plus C will get. In place of circle, if I put minus, LHS will not be equal to RHS. A minus B minus C, right side, left side A minus B plus C. So it is an example of a groupoid which is not semi-group. Next, example of structure, neither groupoid nor semi-group. Can you give an example? Neither groupoid nor semi-group. Here,
N
this is
comma
groupoid.
minus.
N comma minus, correct. It is neither closed. A minus B
Not
does not belong to N.
associative.
And it is not associated. Learn examples. Next one. Let us go for monoid. What are the examples of semi-groups? So I should give examples. What are the examples of semi-groups? So N comma plus. Same set. With minus it is not semi-group. With plus it is semi-group. Same N. With respect to dot it is semi-group. Because dot is associative and A dot B belongs to N. Z comma dot. Z comma plus, etc. And R comma plus, R star comma R comma dot, R star comma dot. R star means removing 0. R means including 0. They are all semi-groups and as well as groupoids. Next one. Monoid. What is a monoid? So an algebraic structure. Algebraic structure means it should be closed. And circle is binary. S comma circle. If I say structure, then A circle B need not be unique. But if I say algebraic structure, then it means circle is binary operation, closed as well as associative. And identity axiom is satisfied. A semi-group. A semi-group. Semi-group means closure as well as associative. Satisfy. Identity axiom. or axiom or a structure satisfying three axioms. Whenever I say structure, I should give you closure also. If it is algebraic structure, you need not define closure. Associative and identity is also called monoid. Here circle, this may be unique, may not be unique. This circle may not be binary operation, but still we can call it as monoid, because sometimes the identity need not be unique in that case. So, are semi-group satisfying identity axiom, both the cases, is called a monoid. What is identity axiom? What is identity axiom is,
A
for
circle
every
equal to
for
circle
every
equal
A or in S, there should exist unique element in S. There should exist an element in S such that A circle E is equal to A, which is E circle for all. Then there exists E belonging to S such that A circle E is A, which is E circle A. Then it is what is called, E is called identity element, and such a structure satisfying having identity is what is called as a monoid. If sometimes what happens is, if A circle E is equal to A is satisfied, then E is called right identity. And if E circle A is equal to A is satisfied, if E circle A is equal to A is satisfied for all A, then E is called left identity. E is called right identity, E is called left identity. So if right identity is equal to left identity, then only we say it is a monoid. So for monoid, E must be here. E's right identity must be equal to left identity. Right identity must be equal to left identity. Okay, this is the one. Now, can you give examples of monoids? Is every monoid a semigroup? Is every monoid a semigroup?
Yes.
Is every monoid a semigroup?
Yes.
Answer is yes.
Yes.
Why yes? Because monoid
Because
means three axioms. Monoid means three axioms: closure, associative, identity. So because it is satisfying closure and associative, it is automatically semigroup. Next, is every semigroup a monoid?
No.
Is every semigroup a monoid?
No.
What is the example?
Uh,
Monoid means
example.
identity should exist.
Yes.
When is it said to be identity? A circle E equal to E circle A equal to A, where E should belong to S.
Yes.
So can you give an example? Is every semigroup a monoid? Answer is, you
No.
said, need not. Is every semigroup a monoid means no.
Need not. No.
There are some semigroups which are not monoids. There are semigroups which are monoid. Is every semigroup a monoid? Answer is no. That no means there are semigroups which are not monoids. So give example of semigroup, because you said no. Give example of semigroup.
N plus.
Not monoid. Not a monoid. Not a monoid means identity should not exist.
Not exist.
Closure and associative should be satisfied, but identity should not exist. So as somebody said,
N comma plus.
n comma plus.
Plus.
Can you give another example?
Mm.
Respect to dot where it is not satisfied. So example is n comma plus. It is satisfying closure or not? Yes. A plus B belongs to N for all AB. It is closed.
0 does not
Next,
belong to N.
it is associative. A plus B plus C is A plus B plus C. Associative is satisfied. But does it have identity?
No, 0
A
doesn't
circle,
belong
A
to
plus
N.
something should be equal to A. That should be equal to something plus A. What should be this element is A plus something. A circle E should be A, which is E circle A. Circle means plus. Therefore, A plus something should be equal to A, which should be equal to E plus A. What should be that number is A plus 0 is A, 0 plus A is A. E is supposed to be 0, but it does not belong to A. It is satisfying condition. A circle E equal to A, which is E circle A. 0 is satisfying. This condition is satisfied, but it is not natural number. Therefore, we say that it is not having identity. Therefore, identity does not exist. Additive identity, the 0 is. So, identity does not exist. Does not exist. Therefore, N comma plus is a semi-group, but not monoid. But not monoid. So sometimes what happens is A circle E equal to E circle A will be satisfied. This condition will be satisfied, but E may not be there in that. So condition is you should be there in the set, not only that A circle E should be equal to E circle A equal to A. That is very important. Very, very interesting. Okay. So is every monoid a groupoid or not? Is every monoid a groupoid or not?
Yes.
Yes.
Yes, because closure is satisfied. And every monoid, every groupoid is not a monoid. Because it may not satisfy, that is associative, it may not satisfy identity also. Next, can you give an example of a monoid with respect to dot? Where with respect to multiplication, it is semi-group, but not a monoid. Semi-group,
Not a monoid.
but not monoid. Can you give an example? Here it is with respect to addition.
Yes.
Semi-group, but not monoid. Example.
2z comma dot.
Correct. Example. 2z comma dot. Why is it so?
One is not
Semi-group?
there in, so
Correct.
identity element.
Semi-group, but not monoid. Majority of the students cannot answer this in the interview also, as well as in the entrance. Which of the following is semi-group but not monoid? 2z. Example. Why is it so? What is 2z means?
Multiplicative
We know
identity is
r
not there.
minus 2 plus r minus 4 and so on. 0 is equal to dot. Here it is semi-group. This is semi-group. Because product of two even integers is again an even integer. Even integers are associative. But which axiom is violated is identity does not exist. Why identity does not exist? If you take any even integer, 2 into something should be 2. It is 1. Minus 2 into 1 is minus 2. Satisfied. Similarly, with respect to 4. 4 into 1, 4. Minus 4 into 1, minus 4, etc. Any integer, any even integer, if you take multiply with 1, you will get A for all A in 2 set. But 1 is not an even. 1 does not belong to 2 set. Therefore, we say that it is not a monoid. Hence, 2z comma dot is not monoid. Next, we have to enter into now group. It is semi-group but not monoid. Let us enter into group. So, group means 4 axioms. A structure satisfying 4 axioms, an algebraic structure. G comma dot or G comma circle satisfying 4 axioms. First one, closure. What's in the closure? A circle B belongs to G. If I am saying algebraic structure, then I need not say closure because it will be automatically satisfied. Algebraic structure means closure is satisfied. So whenever the word algebraic structure is given, closure need not be defined. It will be automatically satisfied. A comma B belongs to G. This is automatically satisfied. You need not state separately. If I say this is a structure or binary operation, satisfying this also means automatically. If it is structure, then you have to define closure. So whenever if you use the word structure, then you have to define closure. Algebraic structure, then you need not check closure. Automatically, every algebraic structure is closed. So you have to check only associative and identity. One more axiom, identity axiom, and one more axiom is, this is special axiom, inverse axiom. What is inverse axiom? I have to define. What is inverse axiom? So for each A corresponding to G, there should exist A prime corresponding to A. For A belonging to G, there should exist corresponding A prime such that A circle A prime is equal to E, which is A prime circle A. For all A, this is for each A it differs. So this is, if A prime only this is satisfied, then A prime is called right inverse of A, because it is to the right of A. A prime circle A is equal to E, then A prime is what is called left inverse. Okay. A circle A prime is equal to A. If it is satisfied, this is not, then A prime is called right inverse of A. Next one, if A prime circle A is equal to E is satisfied, A prime is called left inverse. Okay, so for this group, in a group, if it is a group, in a group, G comma circle E is unique. Identity is right inverse is right identity equal to left identity equal to identity. And inverse is also unique. Unique in the sense, if you change A prime may change. For different elements can have different inverses. But one
Inverse or
cannot have many inverses. One element cannot have many inverses. So inverse unique. A prime corresponding to A is unique. Must be unique. So these are properties of group. If identity is not unique, it is not a group. If inverse is not unique, it is not a group. If you change A, you can get different inverse. But for same A, you should not get two inverses. That's what is the meaning of uniqueness. For example, if it is, if you change Z comma plus, if you take, for 2 plus something should be E, which is 0. For Z plus, identity is 0. So for 2, the inverse will be minus 2. Because minus 2 is also there inside. It is the inverse of 2. Inverse of 2. But if I change the element, you may get different inverse. Minus 3 is the inverse of 3. Corresponding to 2, inverse is minus 2. Minus 3 is the inverse of 3. So for 2, it is not the inverse. For 2, only one inverse, minus 2. For 3, only one inverse, minus 3. And vice versa also you can say. 3 is the inverse of minus 3 also you can say. So, but corresponding to them, inverse is unique means for that element you should get only one inverse. That's how uniqueness is defined. So if all these are satisfied, then it is what is called as a group. If it is a group, automatically it is a monoid. Every group is a groupoid. It is semi-group as well as it is a groupoid, semi-group, monoid. Every group is groupoid, semi-group, monoid. All the three will be satisfied. and in automatically. But every monoid need not be group. Every semi-group need not be group. Every groupoid need not be group. What is the example? Is every monoid a group? What is the answer? Is every monoid a group? Asma?
No, ma'am.
No.
Ma'am, Z comma dot.
Hmm? My share. So is monoid a group? Is every monoid a group?
No.
No.
No, ma'am.
No.
Z
What is the
comma dot.
example? Example of monoid, which is not a group. Answer
N
is no.
comma dot.
So example of monoid, not a group.
Monoid. Okay.
Not a group.
Real number set, madam.
Z comma dot, ma'am.
Real numbers correct. And one more.
Natural.
Z comma dot is correct. N comma dot is correct. So what are the examples? So N comma dot,
N comma dot.
Z
Because
comma dot,
multiplicative.
R comma dot are monoids. What is the identity is 1,
1.
but not groups. Because inverse does not exist.
Exist.
2 is there. 2 into
1
something
by
should
2
be
is not there.
1 by 2. 1 by 2 is not there
Not there in the set.
in N. 1 by 2 is not there in Z. 1 by 2 is not there in R. 1 by 2 is there in R.
Yeah.
1 by 2 is monoid. It is not a group. For this it is there. This is the reason. Hence, it is not. For R, it is there. 1 by 2 belongs to R. But why it is not a group?
At 0, there
In
is
case
no
of these two, for 2 inverse is 1 by 2, but 1 by 2 inverse should belong to the given set. A prime does not belong to N. A prime does not belong to Z in case of 2. In case of R, 1 by 2 is there in R, but not a group. Why it is not a group still? Why it is not a group?
every element has no inverse.
Which one? Which element is not having inverse?
0, madam.
0.
So 0 does not have inverse. But 0 into something cannot be 1 for any A prime. Therefore, 0 does not have inverse. Every other element is having inverse. Here, for natural number, except 1, no number is having inverse. Only for 1 inverse exists. 1 into 1 is 1. 1 is there in N. 1 inverse is 1. Inverse exists for 1. But for 2, 3, 4 and so on, inverse does not exist because inverse of these natural numbers is not a natural number. Similarly, in case of Z also, except 1 and minus 1. Minus 1 also inverse exists. Minus 1 into minus 1, 1, 1 into 1, 1. For these two elements, inverse exists. But for remaining elements, it does not exist. Inverse does not exist. Multiplicative inverse does not exist. Additive inverse exists, but multiplicative inverse does not exist. So these two are not groups. But whereas in case of R, except 0, all other elements are having inverse, except 0. 0 is the only problem. Therefore, example of group is, if you remove that, it is called R star, comma dot is a group. Because all other real numbers, non-zero real numbers are possessing inverse. It is, what is R star means? R minus 0. So R comma dot is not a group. Please remember. But R star comma dot is group. R comma plus is group. In this 0 is included. In this 0 is excluded. R star comma dot is group. Okay, fine. So what are all the groups? What are the examples of groups? Therefore, it may be with respect to plus, it may be with respect to dot. So what are the examples of groups? Z comma plus, Z comma dot no, Z comma minus no, and Z star comma dot is also not a group. Z star comma dot not a group. because not only problem is with 0, with all integers there is problem except 1 and -1. So 2 does not have inverse, 3 does not have inverse in integers. So Z star comma dot is not a group. Only R star comma dot is a group. So Z comma dot is not a group. Z star comma dot is not a group. So next R comma plus is a group. Q comma plus is group. Q star comma dot is a group. R star comma dot is group, etc. Okay, and M by N matrices with matrix addition is a group. And with respect to multiplication, it is not a group because inverse may not exist for all, even if it is square matrix also, inverse may not exist with respect to multiplication. Only when it is non-singular inverse exists. Okay, this is not, these are all the examples. Okay, fine. So one important thing is Z star comma dot is not a group. Because generally students, they think R star comma dot group, Q star comma dot group. So if star is there, it is a group. No. Problem here is not only with the 0, with other elements also. Star means excluding 0. R star means R minus 0. Q star means Q minus 0. Okay. Now, this is not a group. So examples. Next, we have a concept of abelian group. With this, we'll close. Abelian group or commutative group. Here, there is no difference. Only in group, in ring theory, we have a difference between commutative and abelian because 2 operations are coming. Here, only 1 operation, either plus or dot or any operation. So, with respect to 1 operation, abelian or commutative means same. But in ring theory, with respect to 2 operations, it may not be. So, abelian group or commutative group. So what is abelian group means? G comma circle is abelian group, a group. First it has to be group. Group means 4 axioms is abelian group or commutative group. If it is satisfying extra property, abelian. If it satisfies abelian axiom, group satisfying abelian group, if it satisfies abelian axiom. What is abelian axiom? A circle B is equal to B circle A. If circle is plus, generally, then this A plus B is equal to B plus A is satisfied for all AB. Then automatically we say G comma circle is abelian group. General understanding. But in group theory, you can use plus dot also. Sometimes in some textbooks they call it as abelian. But in case of ring theory, it makes difference. Generally, general understanding is this. But in ring theory, second operation, with respect to second operation, if this is satisfied, it is called commutative. With respect to first operation, if it is satisfied, then it is called abelian. This is generally, general understanding is commutative. Because generally we'll be dealing with these two. But in case of ring theory, we'll be having 2 operations. Then A circle B, B circle A. This is called abelian. Abelian. First operation. With respect to second operation, if it is satisfied, whether plus dot anything, then it is what is called commutative. This axiom is called commutative axiom. In case of group theory, only 1 operation will be there. This is called abelian axiom. Remember, in case of ring theory, first with respect to first operation, it is called abelian. With respect to second one, if this is called commutative. This is the understanding. So what are the examples of abelian groups? Examples of abelian groups or commutative groups. Can you give example? Every commutative group is a group, but every group need not be commutative or abelian. So what is the examples of abelian or commutative groups? Z comma plus, R comma plus, Q comma plus, R star comma dot, Q star comma dot, they are all examples. And m by n plus, with respect to plus matrices are abelian, a plus b equal to b plus a. So example of non-commutative or non-abelian, non-commutative group. What is the example? At present, you are having only one example in your hand. So example of non-commutative group means matrices. Because A dot B need not be equal to B dot. Matrix multiplication is non-commutative. Therefore, this is the example. This is infinite non-commutative group. Infinite means how many matrices? Infinitely many. But example of finite non-abelian group. Finite non-commutative. Very important. This is infinite. Why infinite? Because this set is infinite. There are infinitely many matrices. So finite non-commutative group, you will be asked to give examples. What is the example of finite non-commutative or non-abelian group? Can you give an example?
Quaternion group.
Quaternion, correct, good. Quaternion group. That is G is equal to, what is quaternion group? 0, that is, sorry, plus or minus 1, plus or minus I, plus or minus J, plus or minus K. These IJKs have nothing to do with your vector calculus IJKs. In vector calculus, IJK means unit vectors. Here they have nothing to do, they are symbols. They are symbols like A, B, C, D, like that. Here they are denoted by IJK. They are symbols. How they are defined? I square is equal to J square is equal to K square is equal to minus 1. And I dot J is K. And J dot I is minus K. They are like a cross product of vector calculus. I cross J is K, J cross I is minus K. But here we don't use cross, we use dot. It is like that, but they are not our vector calculus vectors. Easily can remember. If it is go say in the clockwise direction, plus, anti-clockwise direction, minus, I into J, K, J into I, minus K. Going in the clockwise, plus, anti-clockwise, minus, I into J, K, J into I, minus K, J into K, I, K dot J, minus. In vector calculus, I dot K, I dot J is 0, J dot K is 0. I am not talking about vector calculus, please. IJK are not vectors. K dot I, J. This is only the way it is defined. This is the definition. So this is called quaternion with 8 elements. How many elements are there? 2, 2, 2, 2. This is the best example of finite non-commutative group. So you'll be asked to give finite non-commutative groups contains how many here? Which of the following is finite non-commutative? So this is the best example. If you go for interview also, they'll be asked to.
Thank you.
So this is about the group. Rings we'll see in the next class. So only I am not going to enter into subgroups and all. I want group, that's all. Abelian group, commutative group for defining a ring. So I am not entering into that. So next class we'll see different ring, integral domain, field. Just 3 definitions. Then jump to linear. Okay. And any doubts, ma? Till now, whatever I have done. Any doubts in the concepts which I have discussed? Are they clear? Is my speed okay? Or you want me to reduce my speed? Can you catch this? Tell me your opinion.
Clarification? Yeah. Thank you, madam.
Any
Any
doubts?
clarification regarding
Any
this context?
clarification? How about speed?
ఏమన్నా
ఏమో చెప్పండి, మీకు ఏమైనా స్పీడ్ ఎక్కువైంది అర్థం కావట్లేదు అంటే విల్ రెడ్యూస్.
చెప్తే ఏమన్నా ఎక్కువ అయిందా? కొంతమంది అంటే ఫ్రెషర్స్ ఎవరైతే ఉంటారో క్యాచ్ చేయలేరు. కొంత టీచింగ్ లో ఉన్న వాళ్ళు మాత్రం 100% క్యాచ్ చేస్తారు. బట్ వన్ థింగ్ ఏంటంటే మేడం చెప్పిన కాంటెక్స్ట్ మరొకసారి చదివి స్టాండర్డ్ బుక్స్ రీడ్ చేస్తూ ఒకసారి థింక్ చేస్తేనే ఆన్సర్ చేయగలుగుతాము. మేడం ఫస్ట్ మంచి క్వశ్చన్ ఎగ్జాంపుల్ తీసుకుంది. మీరు అందరూ ఫాలో అవుతారనే ఉద్దేశంతో మేడం మంచి కాంటెక్స్ట్ తీసుకుంది, డెప్త్కి వెళ్ళారు. కొంచెం స్టడీ చేయాలి, అంతా ఇట్లనే ఉంటుందని కాదు, బట్ కొంత మీరు కూడా ఆ స్టాండర్డ్స్ మెయింటైన్ చేయాలనే ఉద్దేశంతో ఆ ఎగ్జాంపుల్ తీసుకుందండి. జనరల్ గా మామూలు ఎగ్జాంపుల్ తో క్లోజ్ చేస్తారు.
ఏమన్నా ప్రాబ్లం ఉందా మిగిలిన వాళ్ళలో? ఇప్పుడు పార్టిసిపెంట్స్ లో ఎవరికైనా ఏమైనా ఇబ్బంది ఉందమ్మా?
చెప్పండి అమ్మా.
కొంచెం స్వప్న అన్నారు. సో దెన్ యూ కెన్ టెల్ యువర్ అంటే అక్కడ మీరు రైస్ చేయండి అమ్మా హ్యాండ్, లేదంటే ఓపెన్ అయ్యి మీ కెన్ ఆస్క్ మేడం ఇది చెప్పండి, ఇక్కడ తెలుగులో చెప్పండి అని మీరు ఓపెన్. సో విల్ గో అకార్డింగ్లీ. ఇంకెవరైనా ఉన్నారా టీచర్స్? మీరేమి భయపడకండి అమ్మా, యూ విల్ ఈజీలీ ప్రాబ్లం ఏం లేదు, మీరు క్లియర్ చేయగలుగుతారు. ఎందుకంటే టీచర్లు అంటే హార్డ్ వర్కర్ ఉంటారు న్యాచురల్లీ. అందరికీ మన అందులో మ్యాథమెటిక్స్ వాళ్ళంటే 2 క్యారెక్టరిస్టిక్స్ ఉంటాయి: సిన్సియారిటీ, ఓపెన్నెస్, హార్డ్ వర్క్. ఈ 3 క్యారెక్టరిస్టిక్స్ ఆఫ్ మ్యాథ్స్ టీచర్. ఓపెన్గా ఉంటారు, చాలా ఓపెన్గా ఉంటారు. వేరే వాళ్ళలాగా మనకు అసలు అలా మాట్లాడడం రాదు. వీఆర్ వెరీ స్ట్రైట్ ఫార్వర్డ్, ఓపెన్, క్లారిటీగా ఉంటాం మనం. సో అది రెండోది హార్డ్ వర్కింగ్. మూడోది ఏంటంటే ఈజీగా క్యాచ్ చేస్తాం మనం సబ్జెక్ట్, హార్డ్ వర్కింగ్గా ఉంటాం, గ్రాస్పింగ్ ఒకటి ఉంటుంది. కనుక మీకు ఏమైనా ఇబ్బంది ఉంటే చెప్పండి అమ్మా. డెఫినెట్లీ మీరు మాకు ఐడియల్ స్టూడెంట్స్ అనమాట. మీ నుంచి మేము రిజల్ట్ తెప్పించగలిగితే ఇంకా ఘన విజయమే అది, మీలాంటి వాళ్ళకి తీసుకెళ్ళగలిగితే. ఎందుకంటే గ్యాప్ తర్వాత వచ్చారు మీరు. నమ్మరు, ఆ CSIR ఎప్పుడు రాసానో తెలుసా? నేను ఆఫ్టర్ 15 years ఆఫ్ మై పీజీ, నేను 15 years పీజీ తర్వాత నాకు అవసరం లేకపోయింది, నేను రాయలేదు. ఒకసారి నేను సడన్గా అందరూ CSIR కష్టం అవుతుంది అంటారు అని, నేను 15 years అయిపోయాక, ఐ థింక్ వెన్ మై సన్ వాజ్ ఇన్ 6th class, డైరెక్ట్ వాకిన్ CSIR నేను ఫస్ట్ అటెంప్ట్లో క్లియర్ చేశాను. 15 years గ్యాప్ తర్వాత ఫస్ట్ టైం వెళ్ళి నేను క్లియర్ చేశాను. అంటే మన బేసిక్స్ అంత స్ట్రాంగ్గా ఉంటే డెఫినెట్గా క్లియర్ చేయగలం. అంతేగాని గ్యాప్ ఉంది కదా నేను క్లియర్ ఎందుకు, నా ఎగ్జాంపుల్ చెప్తున్నానంటే జనరల్లీ గ్యాప్ ఉంది కదా మనం క్లియర్ చేయగలమా లేదా, ఇవన్నీ బేసిక్ డౌట్స్ వస్తాయి. నాకు కూడా నా మీద డౌట్ ఉండింది, అసలు ఏం ప్రిపేర్ అవ్వలేదు, జస్ట్ అందరూ టఫ్ అంటున్నారు కదా ఒకసారి పేపర్ చూద్దామని వెళ్ళాను, జస్ట్ పేపర్ చూద్దామని. సో నేను క్లియర్ చేసేసుకున్నాను. అట్లా అంటే నా బేసిక్స్ చాలా స్ట్రాంగ్గా ఉన్నాయి. నాకు సెంట్రల్ యూనివర్సిటీలో మా టీచర్స్ అంత బాగా చెప్పారు, ఆ క్రెడిట్ మా టీచర్లదే. డైరెక్ట్ మా బ్లడ్లోకి వెళ్ళిపోయినాయి ఆ కాన్సెప్ట్స్, అందుకు వాకిన్ అయ్యి నేను క్లియర్ చేయగలిగాను. బట్ మీరు ఎక్కడ చేశారో నాకు తెలియదు పీజీ. అదే ఏ సెంట్రల్ యూనివర్సిటీస్లోనూ అంత గొప్ప ప్రొఫెసర్స్ దగ్గర చదువు ఉంటే అసలు ప్రిపరేషనే అక్కర్లేదు, ఎంత గ్యాప్ ఉన్నా సరే. రేపు ఎగ్జామ్ అన్నా ఇవాళ అర్ధరాత్రి లేచి రాయమన్నా రాయగలుగుతారు. కాకపోతే అంత గ్యాప్ అందరికీ, అంత కాన్సెప్ట్స్ అందరికీ ఉండవు, అంత మంచి టీచర్లు అందరికీ దొరకరు. అందుచేత యూ హ్యావ్ టు డూ హార్డ్ వర్క్ అండ్ జాయిన్ కోచింగ్ సెంటర్స్ లైక్ దిస్. సో మా అప్పుడు అసలు కోచింగ్ సెంటర్ అన్నదే లేదు, అసలు చెప్పేవాళ్ళు లేరు, దీన్ని పట్టించుకునేవాళ్ళు లేరు. నాగయ్య సార్ ఎంత గ్రేట్ సర్వీస్ చేస్తున్నారంటే అందరినీ ఒక ప్లాట్ఫామ్ మీద తీసుకొచ్చి ఈజ్ పర్స్యూయింగ్. మీలాంటి వాళ్ళ కోసం ఎవరైతే గ్యాప్స్తో ఉన్నారో, ప్లస్ ఫ్రెషర్స్, అంత స్టాండర్డ్ ఉన్న ప్రొఫెసర్స్ దొరకడం కష్టంగా ఉంది ఇప్పుడు యూనివర్సిటీస్లో కూడా. సో అందుచేతనే అవసరం పడుతుంది ఇలాంటి కోచింగ్ సెంటర్స్ అవసరం. సో సార్ చాలా పెయిన్స్ తీసుకుంటున్నారు. సో యూ షుడ్ డూ హార్డ్ వర్క్. మీరు చేస్తే డెఫినెట్గా విల్ బి ఏబుల్ టు క్లియర్. సో నేను ప్రెసెంట్ ఉన్న స్టేషన్లో అయితే నాకు అస్సలు తీరిక లేదు, దానికి తెలుసు నా పరిస్థితి. నేను ఇక్కడ ఎన్ని పోస్టులో నాకు లేని పోస్ట్ లేదు. ఐఎమ్ వైస్ ప్రిన్సిపల్, COE, కంట్రోలర్ ఆఫ్ ఎగ్జామినేషన్, కెరియర్ గైడెన్స్ కన్వీనర్, నాకు ఇన్ని, అండ్ హెడ్ ఆఫ్ ద డిపార్ట్మెంట్ మ్యాథమెటిక్స్, PG, UG, స్టాటిస్టిక్స్ అన్నీ ఇన్ని పెట్టుకొని, బట్ స్టిల్ నేను నా టైంని స్పేర్ చేస్తున్నాను. మీ క్లాస్ తీసుకోవడం అంటే ఉట్టిగా డైరెక్ట్ నేను వాకింగ్ కాదు కదా, ప్రీవియస్ పేపర్స్ చూడాలి, మీకోసం చేస్తున్న హార్డ్ వర్క్, నా కోసం నేను చేసుకోలేదు అసలు CSIRకి. బట్ మీకోసం చెప్పడానికి మెటీరియల్స్ అన్నీ ఇక్కడ ముందరే నేను రాసేసుకుంటాను ఏమేమి క్వశ్చన్స్ డిస్కస్ చేయాలి అని ఈ నోట్ ప్యాడ్లో. ఎందుకంటే ఇక్కడ వచ్చి టైం వేస్ట్ కాకూడదని ప్రీవియస్ పేపర్స్ అన్నీ సార్ కూడా పంపిస్తూ ఉంటారు మెటీరియల్. ఆ ప్రీవియస్ పేపర్స్ క్వశ్చన్స్ అన్ని ఒక దగ్గర నేను కూర్చొని స్టడీ చేసి ఒక దగ్గర రాసుకొని ఈ రోజు టాపిక్కి ఏం చెప్పాలి అట్లా నేను ప్రిపేర్ అవ్వాలి ఒక 1 or 2 hours. లేకపోతే నేను ఎంత గొప్ప అయినా నేను తీసుకోలేను. కాకపోతే ఏంటంటే ఐఎమ్ టేకింగ్ సో మెనీ పెయిన్స్ ఓన్లీ ఫర్ పీపుల్ లైక్ యూ. సో కనుక మీరు బెనిఫిట్ అవ్వాలి, కంపల్సరీ బెనిఫిట్ అవ్వాలి. సో మీకు ఏమైనా డౌట్స్ ఉంటే మాత్రం ఖచ్చితంగా అడగండి. నేను మధ్యలో నాకు తెలుగులో మాట్లాడాలని గుర్తు చేయండి ఎవరో ఒకళ్ళు, సరితాను నువ్వు ఎవరో ఒకళ్ళు, నేను స్వప్న అని అడుగుతాను. ఇంకెవరైనా ఫ్రెషర్స్ ఉన్నారమ్మా ఇట్లాంటి ప్రాబ్లమ్ ఫేస్ చేస్తున్నారు? నరేంద్ర చెప్పండి. సంతోష్
12 years మ్యామ్ గ్యాప్ వచ్చింది నాకు. జస్ట్ యూట్యూబ్ వీడియోస్, ఎస్పెషల్లీ నాగయ్య సార్ వీడియోస్, ఫెర్మాట్ ఎడ్యుకేషన్ అకాడమీ యూట్యూబ్ వీడియోస్ రీసెంట్ గా 2023లో నేను సెట్ క్లియర్ చేశాను మ్యామ్.
గుడ్.
థ్యాంక్ యూ మ్యామ్, థ్యాంక్ యూ. సార్ యాక్చువల్ గా చాలా గ్యాప్ వచ్చింది మేడం. నేను యాక్చువల్ గా ఉస్మానియా యూనివర్సిటీలో ప్రొఫెసర్ బిఎస్ఆర్ గారు బి సురేందర్ రెడ్డి ఉజ్వల అకాడమీ గారి స్టూడెంట్ మేడం నేను.
ఓకే
యాజ్ వెల్ as సయ్యద్ లతీఫా ఉన్నీసా అండ్ వై రామేశ్వర్ సార్ ఫ్రమ్ సెంట్రల్ యూనివర్సిటీ సార్ మ్యామ్.
యా
సో
ఐ నో సండ్లి
టీచింగ్ ఈజ్ వెరీ వెల్
రామేశ్వర్
మ్యామ్.
సార్
అంటే నాకు మళ్ళీ మ్యామ్
రామేశ్వర్ సార్ హీ వాజ్ మై గైడ్, నా పిహెచ్డి గైడ్ ఆయన. రామేశ్వర్ సార్ నా గైడ్.
he is my professor ma'am. Actually he is my
Oh,
professor
nice,
in
nice, nice.
Saifabad campus in 2009 to 11 ma'am.
Oh, nice, nice, nice.
మ్యామ్ స్మాల్ సబ్మిషన్ మ్యామ్. ఏమంటే ఒకటి ఆల్రెడీ స్వప్న మేడం గారు చెప్పారు, కొంచెం తెలుగు అంటే నేను గ్రాడ్యుయేషన్ వరకు తెలుగు మీడియం మేడం.
తప్పదు సార్.
సో ప్లీజ్ మ్యామ్ ఇంకొక చిన్న సబ్మిషన్ ఏమంటే మేడం మా తరఫున కొంచెం నోట్ చేసుకోవడానికి కొంచెం టైం, కొంచెం మినిట్ టైం ఇస్తే బాగుంటుంది అనేది ఒక చిన్న సబ్మిషన్ మేడం
తప్పదు సార్.
మా తరఫున. థ్యాంక్ యూ మేడం. సెకండ్ విషయం లేదు మేడం, టీచింగ్ ఈజ్ వెరీ వెల్. అంటే మా లెవెల్లో అంటే నాకు ఇంకా 10 years తర్వాత కూడా నాకు అర్థమవుతుంది, 12 years తర్వాత కూడా అర్థమవుతుంది అంటే ఇక ఆల్మోస్ట్ అందరికి అర్థమైనట్టు కదా, నాకు అర్థమైందంటే.
అంతే సార్, తప్పని సార్ మీరు కూడా గుర్తు చేయండి, మధ్యలో తెలుగులో చెప్తాను. సో ఇబ్బంది ఏం
షూర్
లేదు.
మేడం, షూర్.
నేను కాకపోతే నేను మర్చిపోతూ ఉంటాను, అలా ఫ్లోర్లో వెళ్ళిపోతున్నాను. మీరు ప్లీజ్ స్టాప్ మీ.
బేసిక్స్ మీరు తీస్తున్నారు మేడం. ఐఎమ్ వెరీ హ్యాపీ రిగార్డింగ్ యువర్ క్లాస్ మ్యామ్. ఐఎమ్ వెరీ హ్యాపీ.
థ్యాంక్ యూ సార్, థ్యాంక్ యూ. మిగిలిన వాళ్ళకండి నెక్స్ట్ క్లాస్ నుంచి కొంచెం మనం తెలుగులో మాట్లాడుతాను. డెఫినెట్గా ఐ విల్ ట్రై టు రీచ్ యూ. ఓకే, థ్యాంక్ యూ సార్, థ్యాంక్ యూ సో మచ్. 2 hours అయిపోయింది. థ్యాంక్ యూ. టైం తెలియదు మీతో ఉంటే.
కావ్య మేడం నెక్స్ట్ మాట్లాడుకునే టైం ఇస్తాను మీకు, నెక్స్ట్ కూడా డీటెయిల్ గా మాట్లాడుకోవచ్చు. ఒకే రోజు ఎందుకు ఇప్పటికి లేట్ అయింది కదా, మనకి లాంగ్ టర్మ్ కాబట్టి ఇంకా చాలా టైం ఉంది. మీరు మంచిగా డిన్నర్ చేసుకోండి, ఒకసారి మళ్ళీ ఫాలో కాండి, ప్రిపేర్ కాండి. బతుకమ్మ పండుగ రోజు హాలిడేస్ ఇచ్చుకుని యాక్చువల్గా లీవ్ ఇద్దాం అనుకున్న సండే అయినప్పటికీ సరే ఫస్ట్ డే, సెకండ్ డే, థర్డ్ డే అనేది మళ్ళీ ఇబ్బంది కలగకూడదని చెప్పేసి కంటిన్యూస్ గా పెట్టుకున్నాం. అట్లా నో ప్రాబ్లం. చాలా మంది అడుగుతా ఉన్నారు, దసరా ఫెస్టివల్ కదా మాకు ఇప్పుడు హాలిడేస్ ఇచ్చిన పిల్లలకి అంటున్నారు. అవన్నీ కంటిన్యూ చేసి